another test that we're going to be talking about is called the integral test. And the way this test works is that when we have a series that we would like to decide whether it converges or diverges, we're going to look at the terms in this series as a function instead. So I'm going to look at the 1 over n here just as a function. So let me change the variable to 1 over x here, just so because we are more familiar with the functions in terms of x. So instead of looking at this summation, I'm going to look at the integral of this guy instead. I'm going to look at the integral of 1 over x dx when x goes from 1 to infinity. So now then, I have changed from a series to an integral. So I changed from a series to an improper integral. And the thing is, these two guys is going to have the same convergence and divergence status. So if this guy converges, then this guy is going to also converge. If this guy diverges, then this guy is also going to diverge. However, integral tests have some limitations in that the functions that we have here, the function 1 over x that we have here, it has to meet the requirement. It has to be continuous, it has to be positive, and it has to be decreasing function. So then if we look at the function 1 over x that we have down here, so let me just plot the graph for this guy real quick. The graph for 1 over x looks something like this. Now then, on the interval 1 to infinity, this guy is definitely a continuous function. So this guy is definitely continuous. This guy is also positive. So the whole time on the interval of 1 to infinity, so 1 to infinity is about here. So my rate function is all continuous, positive, and it is also decreasing. It is also decreasing. So my function 1 over x meets all the requirements that we have here. So then I can now go ahead and use the integral test. So let's now try to find this integral. Because this is actually an improper integral, I can integrate all the way to infinity. So I'm just going to have to change this to a limit. So I'm going to integrate to just some big N and let my N go to infinity. Now then, the integral of 1 over x is just the log of the absolute value of x. So I'm going to evaluate this at 1 and n, and this is going to equal to just the limit of, let's see, I plug in the value of n, so it's going to be log of n minus, I plug in the 1, so it's going to be just log of 1. And now, because log of 1 is 0, so I'm going to have the limit of log of n when my n goes to infinity. So then when n gets really large, log of n is definitely gonna get really large as well. So this limit is going to be infinity. So that means this integral diverge. So I can now conclude that because the integral diverge, the original series that we have must also diverge. So I can conclude using the integral test that this guy is going to diverge. And this makes sense because this is actually just the harmonic series. This is the p series when p equal to 1. So it diverges. So let's take a look at the next one. I have 1 over n squared, and I'd like to sum this guy from 1 to infinity. So once again, I'm going to change my variable to x, 1 over x squared, and integrate this guy from 1 all the way to infinity. 1 to infinity of this guy. Now, before I can use the integral test, I have to check if my function 1 over x squared here meets all the 3 conditions that we have. Now, if we take a look at the graph of 1 over x squared, it's going to look somewhat like this. So once again, on the interval from 1 to infinity, which is about here, this guy is going to be continuous. Yes, continuous. Continuous. This guy is also going to be positive. And this guy is also going to be decreasing. So then I can now use the integral test with a peace of mind. So this guy is going to equal to, then once again, this is an improper integral, so I'm going to have to change this to the limit of the integral from 1 to n when my n goes to infinity. And it's going to be the integral of 1 over x squared dx. Now, 1 over x squared, this is just x to the negative 2. So let me actually just copy and paste this thing. 1 over x squared is just x to the negative 2. So this is the integral of x to the negative 2 dx. And the integral of x to the negative 2 is just x to the negative 1 over negative 1. So let me just rewrite this as negative 1 over x then. So this is just negative 1 over x, where I'm going to evaluate this thing at 1 and n. So now this limit becomes the limit when n goes to infinity of, let me see, negative 1 over n minus negative 1 over 1. Okay, this is going to equal to the limit when n goes to infinity of, let's see, negative 1 over n plus 1. So then when n gets really large, negative 1 over n is just going to be 0. So I'm going to be left with only 1. So this is going to be just equal to 1. So that means this improper integral converge, it equals to just a number. So this guy converge. When the integral converge, then that means the series also itself has to converge. So this guy is going to converge. And this actually makes sense again because 1 over n, the series 1 over n squared, this is just the p series when the p equal to 2. So then we have seen earlier that this guy is going to converge.